The average cost function for the weekly manufacture of retro portable CD players is given by C bar of X equals 150,000 over X plus 20 plus 0.0001X dollars per player, where X is the number of CD players manufactured per week. Weekly production is currently 3,000 players and is increasing at the rate of 100 players per week. What is happening to the average cost? This question might seem vague, but we will need to answer this question based on the given information. First, we will write this given information in symbolic mathematical symbol. X is the number of CD players, and currently production level is 3,000 players. What that means is that X equals 3,000. And it's increasing as the rate, and so this is the derivative, 100 players per week dx, and the unit for time is t, dt. And so dx over dt equals 100 players per week. Now notice that t is not in the equation given, but we will need to use t because the unit for 100 is players x per week, and we would need to come up with a new variable for that quantity, time. Usually we use t for time. In this case, t is the number of week. And so if production is increasing at the rate of 100 players per week, and the current production is 3,000, we want to know what happened to the average cost when these things are going on here. And so one thing that we are interested in is the quantity dollars per player per week. The dollars per player is already the given average cost, and if we're looking for the rate per week, the rate is again the derivative, and so we will take the derivative of the given equation with respect to t. The given equation is C bar of x equals 150,000 over x plus 20 plus 0.0001x, and we will take the derivative with respect to t because again we want the unit of the average cost per week per time interval. The left hand side is simply the derivative of the cost function with respect to t, whether we put c prime of x bar or ddt c bar of x, it doesn't matter. However, in word problems, we want to use the Leibniz notation, which is dc bar of x over dt. This means derivative of c bar with respect to t. And on the right hand side, we would take the derivative implicitly with respect to t. The variable inside the bracket is x, so we would take the derivative normally and we would multiply dx dt. The derivative of 150,000 x to the negative 1 is minus 150,000 x to the negative 2 using the power rule. The derivative of 20 is 0, a constant, and the derivative of 0.0001x is 0.0001. And again, this is implicit differentiation, so we would need to multiply dx dt. And finally, to answer the question, we simply plug in these given quantities. So dc bar dt of x, where x is given 3,000, equals negative 150,000 over x squared, but again x is 3,000, plus 0.001, close the bracket, times dx dt, but again dx dt is given 100. Evaluate this, we will get negative 1.66, and again the unit for this number is dollars per player per week. And so what is happening to the average cost? At the current production level of 3,000 players, and if the production level is increasing at the rate of 100 players per week, then the average cost would decreases because of the negative sign here. It would decreases $1.66 per player per week.